parents. This is called polyploidy in this example. So the offspring are chromosomes from both the parents. And so the offspring, the Tragopogon marus, is unable to cross-fertilize with the parents. It's become a new species. And in fact, probably about 50% of all the flowering plant species around us, even on this campus, are thought to have arisen by polyploidy, by a multiplying of the total number of chromosomes. And you can also do that artificially in breeding and so forth for plants. Now, generally, animal speciation is a little bit slower. It can be relatively fast. There are some wonderful examples of these big rivers, these big lakes in Africa, such as Lake Victoria. There have been a lot of studies on speciation of a fish there called the cichlids. Cichlid are very common freshwater fish. There are more than 2,000 species of cichlids, and they're mostly found in these Great Lakes of Africa. And their species each live in their ecological niche within a given lake. Maybe some live higher up in the lake, some live lower down, and so forth and so on. And they all have their own particular morphology, their own particular colors, their own particular food chains, and they are quite distinct. And what's interesting is that 500 of these particular species have evolved in Lake Victoria over the past 100,000 years. So here you get fairly rapid speciation in a particular environment that's been very well studied. Now let's come to ourselves. Well, let's be quite clear that in terms of human evolution, it's not that we evolved from apes. Somehow you get this phraseology going around, oh, we evolved from apes. Not really, no. We had a last common ancestor with chimpanzees about 5 or 6 million years ago. And since that time, the chimpanzees have got their own different series of intermediates between that last common ancestor and chimpanzees. And on our side of the equation, as it were, we have maybe 5 or 10 different hominins. They're called hominins, all the many different intermediate species between us and our last common ancestors. And that's the basic understanding of human evolution. Now, we were mentioning yesterday how someone was asking one of the questions, how the world got populated, and we were talking about the out of Africa hypothesis, which has a lot of data supporting it and so forth. And if you can see that map, you'll see how these big arrows are coming out of Africa about 70,000 years ago, the population coming over this way to India, where the weather was very nice. I'm sure they made a good decision there, coming over to India. Then onwards to Australia. There were people in Australia by around 65,000 years ago. Then when the weather got better in Europe, it took a lot of, the weather is still not very good in Europe, especially in my own country, but around 43,000 years ago, people started migrating westwards up into Europe. Around 18,000 years ago, they were wading across that little sea there. If you go up and look at North America, the sea level was very shallow at that time. They were probably wading across into North America and very rapidly populated North America and then South America and so forth. So that's a sort of rough idea of how anatomically modern humans came to populate the world. Now, there are many, many new discoveries being made. The population studies will refine some of those dates, I am sure. But that's a kind of rough idea of the present picture that we have. And as I was mentioning yesterday, from the genetics, simply sequencing human DNA, you can, through computer programming, you can predict that around about 200,000 to 300,000 years ago, there was an initial sort of bottleneck population of about 10,000 people in Africa who were interbreeding with each other. And so it never goes back to 2 people, but it certainly goes back to quite a small population that was living at some stage period of time. When you look at the fossil data, again, we're discovering new fossils all the time, but some of the most recent fossils points to anatomically modern humans of the kind we are all here in this room, between somewhere 200 to 300,000 years ago is where that small population was living. And as I mentioned yesterday, I know that's a bit of a complicated diagram there, but it simply shows there was also some interbreeding, what we call gene flow, or a very polite word is introgression, but basically there was some interbreeding between those anatomically modern humans who came out of Africa and also Neanderthals to some extent, and also the Denisovans, these unknown people based on DNA sequencing data from a cave in northern Siberia where they lived. And initially there was this kind of replacement model, we call it, where this population was coming out of Africa and simply replaced all the other hominin populations in different parts of the world. So that replacement theory has now been, over the past 10 years, has been slightly modified. It wasn't a complete replacement, but there was also some interbreeding with other hominins who were already there. And so in a way now, you could say we've only been clearly a separate species for the past, let's say, 35,000 years, and that's the time when, about 35,000 years ago. And so again, we are a separate species very clearly now, but at the beginning, not quite so clear. And before just leaving the topic of evolution, let's also emphasize that no theory in science, as we were hearing also from Professor Coburn yesterday, it's not a static thing. So it is constantly evolving, it's changing, and there are many interesting ideas about how to expand this theory to make it more efficient and so forth. There's a very famous evolutionary biologist, mathematician called Martin Nowak from Harvard University, who is a Catholic, committed Christian, and he's suggesting that cooperation should be built into evolution as a third component in evolutionary theory. There's also a big discussion going on about group selection versus individual selection, and so on and so on. So there's lots of interesting debates going on in the biological field. So what I've given you is really a very brief summary that I think will be enough for the moment. Right, that's evolution. Okay, we're all starting on the same page then, the theory of evolution. So what about creation? Well, we don't need to spend very much time on this. I know that many here are theological students, and I'm sure these are all things that you know very well. But let's just give a brief summary, highlighting some points, I think, in the doctrine of creation, which are useful in this discussion. And clearly, when we're talking about the Christian understanding of creation, we're thinking about the biblical literature, we're thinking about the early church fathers, we're thinking about Thomas Aquinas, 13th century, we're thinking about reformers like Calvin, who wrote a lot about creation and so on. So really what we're doing here is just giving a very brief little summary really of many, many centuries of theological reflection about the doctrine of creation. And what's worth remembering is we're not talking here about a doctrine that somehow was a response to evolution in some way. I should tell you, by the way, that Darwinian evolution was accepted very rapidly by the main church leaders in my own country and in North America, and there's a very interesting history on that. And it was being taught, evolution was being taught in my own university in Cambridge already by 1865, just 5 years after the publication of The Origin of Species. And it was being taught by Anglican priests, because they were the people doing all the teaching of science in Cambridge at that time. And the kind of questions you have in the exam papers was, discuss Mr. Darwin's theory in its application to something. And you'll find those questions in 1865, okay, in Cambridge University exam papers. Okay, so what is our understanding of creation? We've already talked about this, it's very obvious, but basically God is the source of everything that exists. He is the primary cause of all things. What do we mean by everything that exists? We mean everything. So the laws of nature, mathematical equations, universes, more than one, okay, more than one, if there is more than one, and so forth. We're talking about plants and animals, we're talking about us and rabbits, and everything that exists, Higgs bosons, and so forth. If it exists, it is part of the created order. So God is the author of creation. I've got a quite long quote here. You won't be able to see it. I'm going to read it for you. This is actually from Bill Carroll, who is the Aquinas Fellow of Theology over there in Oxford University, where he spends half his year. He has a very nice summary, really. This is a summary of Thomas Aquinas on one slide. Okay, here we go. So he writes this. He says, God's causality is different from that there is no competition between. We need to limit, as it were, God's causality to make room for the causality of creatures. God causes creatures to be causes. God causes creatures to be causes. Right. Creation is not essentially some distant event. Rather, it is the ongoing, complete causing of the existence of all that is. At this very moment, God not causing to exist, there would be nothing at all. Beginning. Right. There's a lot of theology packed in there, okay? And as I say, that is a sort of brief summary of Thomas' 13th century. And I think we create things. We create art. We create. Starting from materials. So creation. We're starting with the materials that God has already given to us. It's creating those wonderful things that we see all around us in this universe. So it is the primary cause of. And so, of course, we have this great and quite different. And so we cannot guess what Mosiah, where God says, my thoughts are not your thoughts. Neither are your ways my ways, declared the Lord. As the heavens, so are my ways higher than your ways, and my thoughts than your thoughts. Psalmist, Psalm 115, verse 3. Of science. So historians of science have often pointed out that because those early Christian natural philosophers who began modern science believed that, they believed Isaiah, they believed the Psalms, and so that gave a great motivation to do experiments. Because they said, well, we can't guess what God would do. We can't guess how God would work in creation. We have to do experiments to find out how God works. To do whatever in the Psalms. And so that was a motivation then for experimental approach to science. And then along with the transcendence of God in the created order, this involvement of his faithfulness in the moment by moment sustaining the works of creation. And we also find, of course, that this is a Trinitarian creation. Genesis 1:3, Genesis, we have God's ruach, his wind, his spirit, sweeping over the surface of the water. We have God bringing order out of disorder, Genesis 1, and the presence of God in his creation. The whole creation is a fabric woven by the spiritual creation. Again and again we find that Christ is intimately made, that has been made. So created order. And then this wonderful, amazing passage, I think, that you find in the first chapter of Colossians when the Apostle Paul was writing to the church there, and he says that by the Son of God all things were created, things in heaven and on earth, visible and invisible, whether thrones or powers or rulers or authorities, all things were created by him and for him. He is before all things, and in him all things hold together, all things consist. That's an incredible claim to make, isn't it, really? That through Christ, everything, all the physical universe in which we find ourselves, is holding together, it's consisting through Christ. And that is a very remarkable claim to make. And that's what we mean by the immanence of God in creation. Often likened in some way, we have to use picture language, don't we, when we're talking about God. Sometimes picturing God as like a composer of a wonderful symphony of creation, where God is writing the music, God is conducting the music, creation is ongoing. There are 3 tenses of creation in the Bible: past tense, present tense, and future tense. We are looking forward to that new heavens and a new earth in the future. So creation is an ongoing act of this wonderful symphony of creation, and that's one picture that we have. Here's another picture that we have from Charles Raven. Charles Raven was an interesting character. He was the master of Christ College in Cambridge. This is the college where Charles Darwin was a student back in the 1830s. This is later than that, okay, later on, from Charles Raven. He said that God as Father was like an artist deciding to create a picture. God the Son was the design on which the work was modelled, and the Holy Spirit was the creative energy in the artist that created the picture. A rather wonderful picture, Trinitarian picture of God's work in creation. So, what does scientists do? We've already talked about this. Well, if God is the primary cause of all that exists, using the language here of Thomas Aquinas, then everything that exists by the secondary causes, all the secondary causes that God uses to bring about his creation, the physical stuff that we study as scientists. So scientific investigation then is about studying those secondary causes. We cannot study God as primary cause. Now we have to be careful here. So does that mean that God is some sort of divine puppet master, kind of using puppets, so they're all somehow puppets on a string? No, it certainly does not mean that. We don't live in a deterministic universe in that way, because God has given his own integrity to the created order. The creation has its own integrity, its own way of working, its own reproducibility. So matter does what matter does. So we walk outside there, we see a tree growing, it grows in its particular way. We see mosquitoes that come and bite me as they were biting last night. They do things in their own particular way, okay? And so forth. So the creation operates then in its very orderly way. Matter does what matter does. And if it didn't, we wouldn't be here. We wouldn't have any moral choice. We wouldn't know what the consequences were of our actions. And so that is really important for free will, actually. It's really important for moral responsibility, and it's really important to give us the capacity to have fellowship with God. Okay, so I hope by now you're already seeing that we have stories. A evolutionary story which is provided by biology, which is asking the question, how did God do creation? And then we have this parallel creation story provided. Well, why did God do it? What is the meaning of creation? Why are we here? And so forth. And these are parallel stories that are about the same reality, but we're looking out of two different windows to get a picture. Why? So I want to spend this on the title this morning. Questions about this, but I want to just point out one point that people often misunderstand about the theory of evolution. Evolution is a theory of chance. And